Welcome to the September meetup for the Chicago.net mobile development group. First of all, I'd like to say thank you very much to our sponsors, Blue Metal, who are going to come up and tell us a little bit about themselves in a moment, who very kindly sponsored the food and drink this evening, and Microsoft for hosting us in their technology center as a location. Couple of logistic points. If anyone doesn't know, the restrooms are out the back towards the left. So you can find them. Yeah. Plenty of food and drink at the back, so please help yourselves. I believe Blue Metal are going to be raffling a couple of things this evening. So I think Bernard at the end is going to take everyone's names and we'll put them into a generator and we'll select those randomly. So thank you again for that. And yeah, just so anyone is still undecided about Xamarin Evolve, it's 2 weeks' time, October the 6th in Atlanta. Numbers will be going, in fact. For those of you that don't go, a lot of it will be streamed live. If you go to Xamarin's website during the conference, they'll tell you which sessions you can see being streamed. And we will actually be having a presentation, a meetup in October, to go over the key announcements from that conference. I think Mike Stovis is going to be presenting that. He's also one of the presenters. He'll be presenting a couple of sessions that he wrote. Yeah, so no further ado, I'd like to ask, just say thank you to Bernard for presenting this evening. For those of you who don't know, Bernard entered the Xamarin challenge, F-sharp challenge, and won. So he actually developed an app using F-sharp and Xamarin, entered it into the challenge, and he won that. So well done, thank you. And so he's going to be presenting today on a little bit about F-sharp and what it is, and some of the advantages, disadvantages, and how to use Xamarin to use F-sharp for apps in cross-platform manner. But first of all, I'd like to invite Travis up to talk a little bit about Blue Metal and what they do and what they can offer everyone. Thank you.
So welcome everyone, I'm Travis Nielsen. I'm the Practice Lead for Mobility for Blue Metal here in Chicago. For those of you who might not know about Blue Metal, we're a Microsoft partner and a longtime Xamarin partner from the beginning. We have offices here in Chicago, New York, and Boston as well. We will be at the conference as well. We'll have quite a few people there at the conference. So if any of you are going, it'd be great to catch up. So in Chicago, Blue Metal, we work primarily with enterprises in the Chicago area, with kind of a focus on interactive strategy design and then cross-platform development behind that. So that's kind of been our thing for a couple of years. And yeah, for raffle, we have some great prizes. We're bringing the love tonight. It's going to be chocolate and alcohol. So definitely fill out the raffle. So we might as well get started. So thanks a lot for being here and looking forward to it.
Thank you. So no further ado, Bernard, thank you, and the floor's yours.
Thank you, David. Okay, let's see. Cool. Okay, so who here is familiar with Xamarin? Okay, so everybody, almost everybody. So for those of you who don't know, I will summarize it in 2 sentences. You can write mobile apps in .NET or Mono. That's about as quick as a summary as I can do. So I do have a confession to make. I'm not a software engineer by formal training. My background is in chemical engineering and practice of pharmacy. And I'll be able to hopefully give you a different perspective on software development because I did not grow up in the same way as any of you guys did when it comes to writing software. And hopefully, maybe afterwards, you guys could give me some perspective on healthcare from the outside. As I own a startup called All Good People, and we work for Big Pharma. We do preclinical drug risk assessment for them. And I do a lot of the mobile apps as my personal projects for my pharmacist colleagues. Now, when it comes to healthcare, we see a kind of a unsustainable industry. It takes about 20% of the GDP of this country, and if we look back at it, a lot of the problems that we have today stem back from around the 1950s. And this is where software development and healthcare have some similarities, because I would argue that perhaps starting in around 1956, that software development might have begun to have some problems. And there was a guy who worked for IBM named John Backus. This picture is October 56, and you can see he's working on his MacBook Pro. And he's making something. And he's making the first high-level language known as Fortran. And certainly enough, in 1957, him and IBM came together and developed a language known as Fortran. And this was kind of a monumental moment for computer science because it ushered in a new generation of programmers. And here we have Germany in 1970. Looks like the MacBook Pro's got a little bit more sophisticated. We got punch cards up here. I got no idea what they're looking at, but they're programming something. And when you look at the code from around this first generation of programmers, this was taken on the this is the second version of Fortran, Fortran 77. And as you can see, this is typical of the time period. You have goto, and there's no methods, and it's really just one line or several lines, but you have an 80-character column that was probably fed in through cards, and you're just running things procedurally. And around this time in 1977 was the creator of Fortran himself won the ACM Turing Award. And he gave a lecture, which was later published into a paper in 1978, saying, can programming be liberated from the von Neumann style? So this would be this imperative style. Object-oriented programming was just beginning to emerge. C with classes would come out the next year. But in this paper, this scathing paper, where he almost criticizes his own creations, he wrote, and I quote, for 20 years, programming languages have been steadily progressing toward their present condition of obesity. As a result, the study and invention of programming languages has lost much of its excitement. Instead, it is now the province of those who prefer to work with the thick compendia of details rather than wrestle with new ideas. Discussions about programming languages often resemble medieval debates about the number of angels that can dance on the head of a pin instead of exciting contests between fundamentally differing concepts. Well, I didn't know Java existed in '78. But he wrote this, and in this paper, he proposed a new paradigm of functional programming. And it has its roots. What we have today in terms of functional programming has its roots back to this paper, where you can have functions that return functions, and you can compose them in an elegant way. And he wrote this back in the late 70s, but when we look at it, there's perhaps a language that was written in the late 50s known as Lisp, which people today could see as functional. Unfortunately, the ends of all the programs look like this, which is not functional. So let's fast forward to modern times. So 2005, C# is already out. There's .NET. I believe it was version 2.0 around that time. And there was a man named Don Syme in England. And he worked for Microsoft Research, still does. And he set out to make a .NET-based language that was functional, that would have object-oriented qualities, but also be what's known as purely, almost purely functional. And he wrote, functional languages attract me because of their simplicity, even when solving complex tasks. A good functional program is like a beautiful poem. You see the pieces of a solution come together. And this was around 2005. So now we come to our time, 2014. And I just pulled this yesterday. So there's a programming index. I believe it goes through Google to see how many things has been searched or how many terms have been searched for a specific language. And there's F#. That surged from 26 up to 16. And this was yesterday that you see it. And in terms of functional languages, this one is at the top. So what is functional programming? Well, it's difficult to give it a one-line definition. And there's 4 central concepts that appear that in this paradigm that's completely different than what you would know as a C# or a Java developer. So let's begin. And this is probably the toughest concept to grasp at first, is immutable data. So as object-oriented programmers, that's what you grew up with. You create a class, and there's properties in it. So a person class would have name, and you could change the name however you want. Or you have an array of, say, 10 numbers, and you can change the 3rd number in the array. Make it easy, right? Well, you can't do that in a functional language. You regenerate a new array based on a set of rules. And you can play with the array, so to say, but you can't change any of the values within. At least that's pure functional. In F# you can because it has a .NET basis. But something like Haskell, which is a pure functional language, does not allow that. So immutable data. So when it comes to F#, there's no variables because variables change. There's only values. So that means that you can't use a for loop, or you shouldn't use a for loop if you really want to be truly functional. Reason being, say you have for int I equals 0, and then as I is less than 10, you have to iterate I. That means fundamentally you have to increase the value of I every time, which is a mutable data point, and you can't do it. And you also can't use while loops, or you shouldn't use while loops, because inherently to say while something is true, then keep doing this, but that true must turn to false at some point in time, otherwise you have an infinite loop. So again, you shouldn't use while loops in a pure functional paradigm. And as I mentioned, you can't change the values that already exist in an array. You can't change the values that exist in an object. You would create a new object. Now, you might think this might be kind of a pain in the butt. Maybe for very large objects, but for smaller objects and for another one of this tile of functional programming, it makes sense. And let's go to this example first. So the factorial. So any functional programming language book you open, the first thing is going to be factorial. And it's probably one of the easiest things to show on why functional languages really are designed for this kind of application. So in C#, you would have your method factorial, and you would say you have an accumulator. And when you have, you set it equal to 1, and then you run this for loop, and then you multiply by counting up, and then you return the value. Makes sense, but maybe when you were in college at first learning programming, you might not have thought this would make sense. But when it comes to the functional paradigm of doing the factorial, if you think and you embrace the newbie mind, say that you accept the fact that I know nothing about programming, you would say, we're going to let a recursive function named fact, and it is a function that's assigned to a place in memory, and we have a pattern here. These are expressions. So if an argument of fact is 0, we're going to return 1. Otherwise, if it's not 0, it could be anything else, we will say, let's say it's 5. We'll say it's 5 times fact of n minus 1. So we call factorial again, and then say the argument is then 4. And then we pass 4 through, it's not 0, and then it'll be 4 times fact 3. And then it keeps going, and then you get your 120, which is the result. So it's a little bit more clear, provided that you don't you assume that you don't know any programming at all. Now, a second example would be, let's say we want the square, and we want a square of numbers. So we'll say an array, and I messed up on this. It's supposed to say square of numbers I. So we have an array of numbers, and we'll just say it's arbitrary. It's the function argument. And then we multiply every single element within the array by itself. And then we return the sum. Now, in a functional language, it makes it a little bit more clear, because when you look at this, we'll say that sum is equal to sum plus the square of numbers, and you have to read from the right to the left. And in English, you don't really read from right to left. Whereas here in a functional language, we'll say, okay, we have a function named square that takes argument x. It's going to return x times x, and we're going to get the sum of squares of numbers, which we could say is an array, and the compiler deduces the type automatically. And we'll say we'll take that array of numbers, we're going to map it to the function of square, so every single value then gets applied into this function, and then we automatically take the sum of the entire sequence. And that's a little bit more clear than saying, oh, well, we're going to take an array, we're going to iterate through it, and then we're going to return the sum, but we're going to add that sum to a value 0 that's been changed every single time the loop iterates. Now, that second example here, sequence map, sequence sum, I will talk. It brings me to my next point. So function composition is the second key of functional programming, something that you really can't do in something like C#. So there's something called the pipe forward operator, which I've spammed throughout this entire lecture. So what the pipe forward operator means is that you're going to take numbers and you're going to apply it as the argument of sequence map square. And then you apply the sum to it. So you're going from the right to the left, as you would be used to in something like C#. But you say, OK, you take the very last operation, and it should be the last thing in your statement, which makes sense. It's a little bit more intuitive. But remember, you have to think, I don't know anything about programming. Otherwise, you would have thought, well, I would have just made a loop. That would have been the easiest. But again, that's what you're most comfortable with. This is a completely new paradigm. And now if you wanted to do something like this, you would say F# I heart. This actually translates to I heart F#. But you read from right to left, so it makes more sense this way. The other aspect of function composition is something called currying. So remember I had mentioned Haskell, which was one of the first functional languages. There was a logician named Haskell Curry who had a lot to do with lambda calculus. And what's known now as function currying, it has its name. It has his name. And what it says is that you can have a function that returns a function. So this expression of some numbers, x and y, when you think about it in C# terms, you would say that you have two arguments, int x, int y. But here in F#, it's not quite like that. What this is equivalent to, the compiler then reads as, OK, I'm only going to take one of the arguments. We will say let some numbers of x only equals a subfunction. And we're going to actually return the number in the subfunction. But we will return just the subfunction when there's only one argument provided. And this is a difficult concept to grasp at first, because you're used to plugging in all the arguments and then getting a value back, rather than plugging some of the arguments and then getting a function back. And this will cause a lot of problems when you write programs for the first time. So if we say let x equals 5 and we'll say y is equal to 10, we have an intermediate function which is some numbers of 5. So intermediate function is actually a function, and it's a value that is it's assigned as unit, which is in C# you would say is action, a void method. And if you want the actual result itself, you would say let result equals intermediate function, and then we plug in y. So we get this. We get these functions of functions that pass through each other, and then we get our final result. And this is useful. I will show you in our example how it can be. At first, you might think, what's the point? But there's a lot of generalization that you can do to abstract things out, given this. And the third tau of functional programming is pattern matching. So we can see pattern matching as kind of a switch case statement. And here, it's very much like what you would see in C#. You would say a function is odd, returns bool, and takes integer x. And we will say match is odd x with, and is odd x will either only return true or false. So we'll say true. If it's true, then we'll say it's odd. And if it's false, then we'll say it's even. So in this sense, switch case statement's fairly simple. But now the real power of it is that anything can be an expression that you can match. So you can dynamically create whatever you want and match the pattern to it. And what I mean by that is you can say, we'll compare tuples. And it could be an arbitrary function. So tuple compare will take in an argument of type tuple, which could be anything. In this case, they should be ints. And we'll say, OK, if they're both 0, then we hit this expression, and we will return this function. We will print tuple of 2 zeros. If one of them is 0, then we'll say tuple of 1 0. And we'll say if the left-hand value, the first value, is greater than the second value, then it has a larger left-hand side. And we can keep going. And is it possible that we could hit the pattern down here? And the answer would be yes. You would, if you're a QA engineer, you know you can order -1 beers and then see what happens to your program, and you would get here. And it gives you some kind of safety that perhaps your function, if something is plugged in that shouldn't be, you can catch it with pattern matching. And also, you can pretty much create whatever you want and use that as an expression to match the patterns. And we'll see that in the example that I'm going to show. The last tau of functional programming is lazy evaluation. So in F# specifically, this is not turned on by default. But in a language like Haskell, which has more pure functional features, everything is lazy evaluated, which would help in terms of what we're doing. Because you have these functions that create objects, and you don't have the actual objects themselves. You're given a set of rules to follow to create things, which would help with the memory optimization. But here in F# specifically, because of .NET, we can create lazy types. And if you're not familiar with these in C#, they're very nice. A lot of the Xamarin examples use them for very memory-heavy objects. And we can then say we have a function of a lazy integer that we could just create using an arbitrary function. And we don't evaluate it until we call x. And that's the last tau of functional programming. So we'll begin with some of the demos here. And the first one I'm going to show is not specific to mobile apps, but it'll show you F# by itself. So we'll file new project, and I will be live coding, so help me God. But we'll go to new solution, and we will create a F# console project. That's not it. And we'll say my first F# prog. So here we're going to use F# data, and it's a library that was created in part by the actual creator of F# himself, Don Syme. And we will mine the World Bank for some of the data that it has. So it's very good. We have NuGet here for Xamarin, so we can say f#.data. We'll search for it, and there it is. So what's very nice about this is that it has a type provider. And let me show you what that means. As soon as I didn't click cancel, did I? Oh, there it is. Okay, and we'll say open. I gotta make that bigger too. Can you guys see that? Cool. Okay. So let's go to the World Bank site. And we can see they got a lot of things on a lot of different countries. And if we want to check out one of the indicators, we'll get this XML file. Let's see if I can make it bigger. So we get this XML file that has the indicator, which would be population total. We have the country, United States, and the year 2013, and we have the value of the population as projected by the World Bank. So if you wanted to mine this in C#, you would, it'd be kind of a pain. You'd have to find out the schema of the XML, find, get the HTTP requests, all that. And you'd have to write objects that would correlate to the things that, these values. Whereas here in F#, what we can do, data, okay, let's say we need to deduce what an indicator is. So I'm going to take a wild guess in the dark because I know. Latest indicator. So now what this means is we have a function named latest that takes in argument indicator, and the compiler will determine the type of indicator dynamically. And we're going to pipe it forward to say indicator. It's a list of tuples. I'll say that right now. So we'll say sequence, which is the alias for array in F#, and we will max it by the first value because it's a tuple, so that's the year, and then we will pipe it forward to say we'll select the second value. And let me spell things right here. Okay, so if we say let America equals data dot, oh, I have to get the context first. So let data equals World Bank data dot get context, and let's say data dot countries dot United States. It's amazing that even the IntelliSense appears within mining this World Bank data. So we'll say United States, and we use the double back quotation marks, means a literal string in F#. So we have America is a value, and it is United States. And we will say print function, and %a means print anything. It could be whatever object, and it will print it. We will say latest dot, and we'll say indicators, and we can say population total, and put those in parentheses. And then we will run it. Oh boy. Good thing I have this. So a little bit more advanced part of the demo here, but what we're going to do is, you really can't see that, can you? There we go. I'll need to call it from the other console, but now we have the United States, and I added in a few other countries, Canada and China, and these are all the these particular ones are the expenditures on GDP per year. So this would be in the year 2013. And here, well, let's go back to the code here. So we have we get the context from the data, and we'll say the indicator. So we get the highest year, and then we get the value that corresponds to it. So data from indicator will so data from is the name of the function, and indicator is the same indicator as used here. That's the function argument, and we get the years. So the indicator itself is a list of tuples, and we just get the first value and put them into an array. So that's years is an array of integers that is just the number of years, or whichever years you're talking about. and then we'll say let numbers be the values that correspond to each year. And then we're going to write the indicator, and then from the numbers, which are the values that correspond to all of the values, we'll say we're going to iterate through numbers using a second array with an anonymous function that takes two arguments, arbitrarily named x and y, and we will write the year and the value, and we will say years. So right here we're using function currying, and the reason being is that we know that we're applying our iteration to numbers, but the equivalent of this would be this, that we could say, and this is what you might be used to in C#, Java, any of those languages. You would say we're going to iterate through two arrays, one of which is years and then the other is numbers, where x corresponds to all the values within years and y corresponds to all values within numbers. And we will at the same time call the function that's anonymous right here, and we'll print out both the values of x and y. And here I created countries, which is just a regular array, and it's just an array of countries. And from here, we'll say, okay, we'll take the countries array, we're going to iterate through it, and each country will be the value of x per iteration. We're going to write with a new line, x, the name of the country, and then we're going to say fraction of children is the latest indicator, so 2013, population ages 0 to 14, and we'll divide it by 100 because it is a percentage. And then we'll say the number of people total is the population total from indicators. And then we'll print out both fraction of children and number of people. And when we run this, let's see. That's no good. Looks like I can't get it from the console. But when we run it, we then get you guys can see that, right? So we get the total number of children that exist in each country, which in America here, it looks like it's 61 million, and in China, it's 244 million. A lot of people. So a simple example of using F# to mine data. And you can do this for several different countries. Let's say we wanted to add in, nope, not you. Let's say Syrian Arab Republic, we can do that. And from the indicators, there's a whole number of things we can do. So health care equals indicators, and we can go all the way down. There are so many of them. We'll say healthcare expenditure. They have some really odd statistics in here if you keep going. I found this last night, and it turns out it's not reported. And let's see, I might have to make this smaller. So women who believe a husband is justified in beating his wife for burning the food, which is not a reportable statistic. I don't know why that's in the World Bank, but it shows up in the IntelliSense, and it is supposedly a World Bank statistic. And it doesn't return any numbers, any of them, at least for America. And I don't know which country would. But this is a simple way of using F#. And in just 32 lines, you were able to do what would have taken you a few hours to get the type, and then to create the type, to find the schema, and keep going. I just did it in 5 minutes in a simple demo in 30 lines. So power of F#. Now, let's go to the second demo, the game of life. So anybody heard of the game of life? John Conway, 1970. So there's a mathematician in England, and he got tenure relatively young in his life, and he kind of sat around and thought about life. And he said, well, is it possible that we can create some kind of life based on an arbitrary set of rules? So let me show you here. I wrote a blog post. I wrote an Android version of it in Java. And here, the 4 rules are an alive cell So we'll have a game board, let's say 20 by 20. And a cell that's black is going to be alive, and a cell that's white is dead. And an alive cell with 0 or 1 neighbors, it dies in the next generation because of underpopulation. And if it has more than 3 neighbors, it dies of overpopulation. But if there's 2 or 3 alive neighbors within any cell that's alive, it will live to the next generation. And the last rule is that a dead cell with exactly 3 neighbors will come to life in the next generation. So you can see this would be a case for pattern matching, because we have 3 patterns here. We have 2 alive, we have 3 alive, and something else. And we can use that in F#. So this is a little example of what the Android version looks like. And there's actually a live demo here, emergentmind.com. And he actually just made it in JavaScript. And you'll see that, hey, these are little colonies that are replicating with each other here on this game board. And as we go faster, you'll see that it almost looks like colonies of bacteria fighting. And it almost turns into a game, right? You look at it and you're like, oh, okay, that looks neat. In terms of being life, maybe not quite there. It can't self-reproduce. But there's something there. And it's really only 4 arbitrary rules. So let's go into code. And here I will show you. This is going to be our target. Oh, wow, that's big. Cool. So our target is going to be something like this, right? Where we have dead cells, alive cells. We will iterate, and we'll start counting. And it'll say, hey, look at these objects, right? So when we go to the code, we'll say new project and an F# iOS. And the thing with Xamarin is that if you have the Visual Studio plugin with the professional $1,000 a year version, you actually still can't do F#. It's only for Xamarin Studio on the Mac. And I don't know if they have, I'm pretty sure they have some kind of plans to get it in for the Visual Studio plugin, but not quite yet. So we'll go into Classic API, iPhone, and empty project. And we'll say my game of life, iPhone. We will create. We will close this out. So here, anybody who's a seasoned iOS champ knows, hey, this looks really familiar. But it's different at the same time, right? You're opening instead of using. You have this type instead of class, and then you have this module main, right? And then it's not even void main args, it's let main args, right? And what we're going to do here is we're going to add a file here and say game home view controller. And this is one of the pitfalls of doing F# in Xamarin, is that the tools aren't quite up to par with C#. You do need to do things like this: open mono touch dot. I don't know a faster way to get it to resolve any of the usings that you need. It might exist. I haven't found it. And let's say UI kit. And OK, we'll say the type home view controller, which is equivalent to what you know as class. We'll say it's as this. So we have the reference to itself. And then it needs to inherit UI view controller. OK. And now that we have this, there isn't actually a constructor that you would call, say, public home view controller. What you need to do is you would use do. And then you can say this dot title and the equals, because remember, we don't want to mute data. We don't want mutable data in F#. But because iOS and the API is written in something of an object-oriented language, you would need to mutate the data anyways. So instead of saying equals, which would game of life, this wouldn't work. You're not assigning, you're assigning a value that should be mutable. So you have to do this, no, not frown face. You have to do a back arrow to say we're going to rewrite the value of title to game of life. So all of these things, and then if you are familiar, we can say override view did load equals base view did load. So many of the similarities with C# and also Objective-C. These are the same. Why are you this? And these are the same methods that are being called. And it's really the design of it. And you have to do it this way. The other thing that has to do with F# is that everything is compiled from top down. So remember I talked about the Fortran and the goto statements? This is a similarity. Because if you try to run this and app delegate is up here, say your entry point of main is not the last file and the last function to be compiled, it will give you, it'll yell at you saying that it has to be the last one. So you're going to have to drag and drop home view controller above app delegate, and then it will run. Because it goes from top down. So if you have views and view controllers and your models, you would need to put your model at the top, your views, and then your view controller and view controllers, and then you would have to go to main as the very last function. And I don't think, there it is. And the other issue is that sometimes it doesn't error parse all that well either. Oh, and it's setting to deploy to device. I don't have a device connected, but you have the confidence that it runs. So now let's think about the game of life. We have the rule of 2, 3 neighbors, and anything else. And let's get started here. If we look at the code here, I've already set it up. And what we have here is we have our app delegate at the very bottom, and we have our home view controller, which is an intermediate, and it's going to show all of our views. And we have a lot of them. So because because iOS was designed using an object-oriented imperative language, you cannot get away with using F# in a purely functional manner here. You can do it for your model, but you can't do it for your views, and you can't do it for your UI. But you can get very close to it. So here, I am using for loops, and that means that I am using mutable data, and I'm setting frames, and I'm refreshing colors that match a pattern, and we are mutating a lot of data here. So above the view controller would be the game of life, which is our model. And this is where we can have real functional programming, where we can state an arbitrary type named cell. And when we have this line here, which would be shift /, that's actually an expression. It's an arbitrary word that represents something. You will pattern match to it later, but you can't. Nothing like this quite exists in C#. And we can say that a cell can either be dead or alive, and we will match those patterns later. And we'll set the board using random numbers. And we will, what we do is we create a 2-dimensional array, 20 by 20, using the function, an anonymous function that takes 2 arguments, because you have an x and a y coordinate for each one of the elements in the array. And then we will say, OK, now we're going to keep calling random numbers as this array is being initialized. And we'll say we're going to call a random number between 1 and 100. And we will match that expression with some arbitrary value. And when it's less than 50, then say it's alive. Otherwise, we'll say it's dead. And right now, the UI doesn't really care what is dead, what's alive. It doesn't mean anything just yet. And we have some more functions here. So flatten board, when we create the views, the 20 by 20 board, it's going to be a 1-dimensional array that has several different rectangles in it. And it goes from left to right, top to down. And we will then get the amount, the number of neighbors for each cell. And this, we can talk about this function later. But life cycle is going to be every time that we iterate the board, what we're going to do is we'll say we're going to create a new two-dimensional array based on the length of, based on the first value and the second value, the x and the y value of the two-dimensional array that's passed in, which is board. And then we're going to say we're going to get the number of neighbors and we're going to match it. So this is our statement that fits all of the rules of the game of life, where we say if we have two neighbors, we're going to determine whether or not the cell is alive. And if it is alive, it continues. And if it's dead, it's created as a new cell. And if it has three, no matter what, it will be alive. Anything else, consider that cell dead. And here, when we hook it up to the view controller, this is where things get kind of sticky, because we have a mutable function called views, where we create 400 squares because it's a 20 by 20 board, and we will say we'll just create a view, and then we have to create an array of rectangles for the frame of each view, and then we refresh the colors. So we're going to match every element within the board with what's either alive or dead. So if it's alive, it'll be black. If it's dead, it'll be white. And then we have our event handler, which you can take. Remember, it takes sender, object sender, event args e. So we don't even need to say what those are. They're just something anonymous, underscores. They could be whatever. It doesn't matter. And we run it through a while loop, which is, again, not functional language, but it's acceptable for this case because we are running on an imperative programmed API. And then, of course, we're going to initialize the view controller, which shows up as the very last thing that we do. So we commit we do all these things, we commit them to memory, these functions, and then we do the initializing. And on the very first time that we create the view controller, we go through the views and we'll say, okay, we're going to flatten out the board that we initialized earlier and then correspond all the colors based on whether or not they're alive or dead. So let's go ahead and run this. And of course, let's see. Oh boy. Good old demo gods. Good thing I have it in here already. So we run it, the build magically worked, and now we have this. So we initialized that two-dimensional array, and we corresponded it to the views, and now we have a random number of what's alive and what's dead. We'll iterate it, and it'll run in an infinite loop, and you will see it automatically calculates for you the game of life until we get to things that are stills, and then they die. So I have a C# equivalent of this, and it uses a lot more code. So if you look at the model here, this is maybe what you're more comfortable with seeing, that you have a height and a width. You have a Boolean array of cells, because you can't say type alive or type cell is either alive or dead. You can say it could be ones or zeros, or give it some other value, but the two values have to be different. So we used a Boolean array, and we created the things as you would in an object-oriented programming language. And we have all of these functions, and we have all of these arrays, all these properties, and look at how many lines of code it is. Rather than simply matching a pattern to 2, 3, or anything, we have to go and we have to look at, is it going to be alive afterwards, and how many number of neighbors are there? And we have to determine whether or not things will live in the next generation. We base it on states, and then we iterate through the views, and it's a little cumbersome for the model itself. So this would be the advantage of the functional programming. Now, as this keeps going, exit out of that. Okay. The advantage to the C# version would be in the view controller itself, where it's a lot easier because you can mutate data as the language had designed. So you have a pro and a con when it comes to specifically writing F# apps on iOS. And I don't have an Android demo, but, or I don't have a demo in code. I can show you here, as soon as the emulator isn't dead, which it might be. But the same thing was achieved on Android. Looks like it's dead. And this code is all on GitHub. I'll post it up on the meetup afterwards. So let's go back to our presentation here. So when it comes to writing F# apps using Xamarin through Mono, we'll say, you know, the tools are ready. The IDE is fantastic, but it's not quite up to C# par. You can't resolve usings. The IntelliSense, you still have to press Control Space for it. You have to drag and drop files in order. It's a design of the language, but it's ready for production. It's just not as good as C#. And when you look at it, iOS, Android, Windows Phone, Windows 8, those are all object-oriented. They're built on object-oriented languages. So you cannot use pure functional paradigm when it comes to doing these apps. But you can use it for your model, which would be good. And other than that, my own critique of the language is that it's difficult to learn at first. But if you can, once you sit through it and say, okay, I don't know anything about programming, I'm willing to sit through and relearn everything, eventually what you do get is a new understanding of what you can and can't do in either paradigm, and you ultimately become a better developer as a result of it. So I'd like to take any questions you guys might have. David.
It seems like, I think I'm hearing you say that there are times when the object-oriented paradigm of C# is more appropriate for application.
Yeah.
And expressiveness of F#. Are there any guidelines about looking at that to figure out which language I should be choosing, assuming that I'm pushing mode?
Yeah, so I mean, in terms of like published guidelines.
Or just your own opinion?
Oh, my own opinion. Well, it depends on what you want to do, right? I mean, you could create an F# library and call it in C#. You could do that. But in terms of, if you're working with data, right, you can script things very quickly in F#. You can get it to do what you want. So that the World Bank example that I had shown, if you wanted to run into some kind of Excel interrupt, you wanted to write a bunch of CSV files and then autoplot using F#, it would be very quick. It would be very easy to do in F#. But if it's C#, it would be a little bit more difficult. And again, even with just the World Bank, you'd have to create the type provider, or you'd have to create the types manually and figure out the schema, all those things. It's built in and done for you using the F# data library. So it depends on your application. They're also MVC 5 is now in F#, and I think that was an open source project that was done. It's out on GitHub, and you can run ASP.NET MVC using F#, which I think is pretty crazy. But when it comes to, let's say you want to write a blog engine, and you have a big database that you have to work with, that'd be a fantastic application for it.
So how would you, could you show us how you would call an F# function? So at least my view on this is that, at least from the UI perspective, it's probably going to be more suitable to write your UI specific stuff in C# and then create, as you suggested, function libraries or business code in F# if it's suitable.
Yeah.
So given that, could you show us an example of how you would call an F# functional or F#? An F#
You mean from C#?
From C#.
Well, you need to create some. You need to create a DLL and then call into it. I actually go the other way around. I have a blog post that talks about calling Fortran from F# and calling Fortran from C#. But yeah. See, when it comes to that, I actually haven't worked with that. You would need to compile the DLL and then reference it, and then you can do it from there. But I don't believe that you can have you can have a C# project and an F# project in the same solution and say that one references the other. I don't believe you can do that because they use different compilers. But they all compile to .NET IL. But in the same project, I don't believe you can do it. So you'd have to manually create the DLL aside.
It's still managed code.
It's still managed code. Yeah, it all goes to the same IL. It's like Visual Basic goes to the same IL. But whether or not you want to mix Visual Basic and C# code, you probably don't want to do that. Yes?
I can add a little bit more insight on that because I've done it.
Okay.
You do have to put them inside the assembly.
Okay.
And a lot of the F# specific types, like functions, are represented as objects on the C side.
Okay.
So they're actually a little bit. But F# also has a lot of facilities for instead constructing so that it will naturally compile this kind of objects.
Okay.
That you would interact with and any for example, for functions, if you have them take a tuple as an argument, then it'll just compile down to a standard like C# style function.
Perfect. So what I did notice, if you look here, oh, that's C#, wrong language. If you look here, you'll see actually you'll see, oh, it doesn't show here, full name. If you look there, full name, game of life, iPhone.HomeViewController. So that is what you would represent. That's what you would use to call in C# because that's the actual symbol of that object, and it would be seen as an object by C#. Yeah. Yes, Lars.
There's no go-to.
No. Well, we use a Fortran 77 library when we do our pharmacokinetic simulations. And believe it or not, you have 30-year-old code that can write a 10 gigabyte file in about 10 seconds. I think back in 1980, no one ever even imagined that was possible. I mean, the world's storage space, I was talking with Simon, it was world storage space in 1980 was probably only 10 gigabytes, right? And now you have code that was written back then that can do it, and it's fantastic. So will this stand the test of time? We will see. I believe it will, and it will evolve in appropriate fashion.
So
Yeah.
what about performance?
Yeah.
Compared to other languages like C#?
Yeah, so it depends on how you want to optimize it. So there are things that you just wouldn't do in C#, like say run a pharmacokinetic simulation, but it might be easier to develop in F#. You don't want to do things like recreate large objects without copy constructors, those kinds of things. In terms of performance, this code runs fairly well. I know that there's a few optimization things that I need to do, and this is just not functional at all. This is writing it in C#. And there's ways that you can do it. You can iterate 2 arrays at the same time and then assign them a frame. I didn't do it that way, although the code is down here. And for some odd reason, it doesn't quite work. You'll still need some kind of index to count up as you go up in the X and the Y coordinates. But it's for some odd reason, I left the code in, and it's in the repository. It doesn't really work that well. You get something that's not game of life. And last thing I want to show you guys was the contest I had won back in July. This was the app. It's actually published for Android and iOS, and it was the evolution of color. So I was using a genetic algorithm. I was on a plane out to San Francisco to talk to a company, and I thought, is it possible that I could write a visual genetic algorithm that might be a little bit representative of what we do at All Good People. And I thought, well, can we do colors? And can we do it in a mobile app using iOS? So this is what I came up with. So you have a board, a grid, so you can already start to see my style here. You have a 10 by 10 board, and what you want to do is you want to figure out a target color. So this shade of purple is our target. And this entire board is called a population, and each population has citizens. Each citizen has 24 chromosomes, much like, let's say, model it like a human, right? And the chromosomes are a string. It's a string of ones and zeros, and that's how you're going to get the color from a binary value. So what we're going to have the algorithm do is we're going to say, okay, the most fit member of the population is going to be placed up here, and the least fit is going to be placed down here. And we consider fitness by how close each one of the chromosomes is to the target. We're going to sort them by fitness, and we'll say the top 15%, so the top 15 members here, we're not going to mutate at all. But the bottom 85%, we're going to randomly mate them together. So this one could be, the first 5 chromosomes could be added to the last 19 chromosomes of this one, and we'll go all the way to the end. And then we're done with the mating. And then we will say 25% of every single member will be mutated by 1. So if one part of the chromosome is a 0, we'll turn it into a 1. If it's a 1, it's a 0. And then sort it again, and then we'll mate, mutate, and sort. And we'll keep going. And eventually you will get the target color. And I'll show you. As we go from one population to another, a parent to a child, you'll see that purple begins to overtake the population until it gains some momentum and then takes it over completely. And then we pause and we'll say, okay, we'll find a new target, which is a brown. And you will see as the population quickly turns into brown. So I did this in F# because you're going to recreate a new generation every single time on every iteration. We'll base it on something similar to how humans work, or with random mutations and mating and new populations every single time. And you will see the population change visually as we go through the generations. So that was the app I wrote for the contest, and the folks out in San Francisco liked it, and now I'm up here giving an F# talk.
Can I ask why you get paid for them?
Oh, it was just for colors. It was for to get the binary value of a color. Yeah. So it's actually a string, and that's probably what could make it slow, is that you're comparing by strings each single value for 100 things. So 100 times 24 every single generation. You keep sorting, and it could be slow. It's not, and it's a good thing. And that code is up public also on the same GitHub that I'll post to the meetup. So if you guys want to inspect the code, F# and C# versions are there. Yeah, Matt.
I have a question. What is all good?
So we do preclinical drug risk assessment for big pharma. So pharmaceutical companies every day discover thousands of lead compounds that could be used for, it could be used to treat any number of diseases, right? And what they do, believe it or not, they discover these compounds from a lead, and they'll say, okay, we're gonna try it on all these chemical assays, and they have this array of test tubes. They take the compound and they say, okay, now we're gonna pour this number of drugs into into each one of these test tubes, and we'll test by HPLC or however they want to do it, how well the drug would bind to this assay, which would simulate some kind of protein binding or some kind of target action. And from there, if it binds a certain amount, they do more tests, and if it passes those tests, then which are all done manually by hand, then they say, okay, we have a possible compound that we can test in animals. And if it passes the animal tests, then we can do what's called first-in-man study, and we'll apply a new drug application to the FDA, who will then give us approval to do these studies, and we'll test it in people. And where we come in is that we do pharmacokinetic testing in silico. So we have simulations, mathematical simulations with a genomic basis, and we're able to test, because we've sequenced the human genome for 10 years now, we're able to test whether or not these drugs will work on a number of protein markers that we know exist based on the human genome. So with that, we would be a value added to them because they would be able to determine quickly which compounds could be viable to begin animal testing. So we're at the animal testing phase right now. Ultimately, we would like to get to a human phase where we could say, my genome sequenced and everybody in this room's genome is sequenced. Now let's inflate a population of every single person, create 10,000 copies of each, and we will then begin passing through these drug candidates into each person. We'll have mathematical markers for congestive heart failure, diabetes, obesity, any one of those disease states. And we could say with some certainty, let's say 6,000 of me out of 10,000 got a heart attack from taking a drug. We could say with some certainty that 60% chance I would get a heart attack from taking a certain medicine. So that's All Good People and what we do. Thank you. It is true, yeah. But if we can sequence everyone's genome and use it from there, that is one step closer to personalized medicine, individual medicine. The way medicine is going now, and I see it because I work in healthcare, everything's evidence-based. So they aggregate 250 people in a study, and they find the statistics on that, and they'll say, okay, well, 13% of them got a heart attack from taking this medicine. So now you have a 13% chance of getting a heart attack from taking this medicine. It's simply not true, because you are not any of the people in that study, and your demographic information would be different than any single one of them. Thank you. Okay, cool. So we're going to do our raffle.
Just before we do the raffle, can I just ask everyone? So, thank you everyone. Thank you, Bernard. One of the things I wanted to ask everyone here is if there are any topics that you guys want us to try and cover, in some of the coming meetups, and any particular topics, or do you want us to carry on sort of presenting? Are you interested in more meetups where we show how it can be used, like Bernard's presentation tonight and the iBeacon presentation last month, or would you like more sort of lesson-based presentations where we show you how you can use form, Xamarin forms and things like that? We sort of, if you guys have any particular desires or wants where in terms of the presentations we're doing, we'd really like your feedback. So if you've got any views on that, see myself or Bernard this evening, or fire us an email, or put a post on either the Chicago.NET Mobile Developers community in Google Plus, or on our meetup page. We'll try and get, more feedback we get, the better we can make this more suitable for what the membership wants. I appreciate that. Thank you very much. Thank you again, Bernard.
All right, so Matt, what do we have to raffle off?
So we've got a choice. So we did something interesting at the last .NET user group. We had bottles of wine, we had technology gifts, and we had certificates for training. Guess which ones went first?
Alcohol.
Yeah. So we changed it up a little bit. Not everyone likes alcohol, so we've actually got two things. We got different types of alcohol. We have very high-end Godiva chocolates. So either one of those, most people. So we've got some Goût champagne. We have some Eldorado 15-year-old rum, which is very nice set rum. We have Macallan Club, and we have 2 sets of Godiva chocolate.
Macallan?
We have Macallan. Please don't consume these before you know. But what I thought we'd do is we have you choose the names.
Okay, yes.